Very good afternoon to all. So we have started with convolution theorem in last lecture. Okay. So the statement is if, can you just tell me the statement of convolution theorem? If
f1 of t and f2 of t are two
right,
functions.
right, and Laplace inverse of f1s is equal to say
F1 of
f1t, right, and Laplace inverse of f2s is equal to f2t. We get functions of t, we call it any one of it as f1 and other as f2. Then Laplace inverse of f1s. Is this visible?
Yes.
F1s into f2s, it is by convolution theorem integration from 0 to t f1u into f2t minus u du. So it can be like f1t minus u, f2u, but any one of it should be u and the other should be t minus u. Okay, so this is the statement of convolution theorem. So we'll take the next question in that. All have joined. Okay, the question is find Laplace inverse of s upon s square plus a square, sorry, s square upon s square plus a square bracket square by convolution theorem. By convolution theorem. Okay, so convolution theorem, for that there should be two functions of s multiplied. So can you just identify the two functions here? Which two are multiplied? In this, there are multiplication of two such standard functions whose Laplace inverse we can easily find. So which two are there?
Yes, upon a
Square plus a
square.
Right. S upon s square plus a square and again s upon s square plus a square. If you are taking s square upon s square plus a square and 1 upon, but that s square will not have the formula, right? Formula is s upon. So there are two such functions multiplied. So I'll call one as f1s and other as f2s. So f1s is s upon s square plus a square and f2s is similar, s upon s square plus a square. These two are multiplied here so that it becomes s square upon s square plus a square bracket square. Okay, two functions of s we have identified. So next is we have to take the Laplace inverse of them. So Laplace inverse of f1s, that is Laplace inverse of s upon s square plus a square. What is that?
cos 80.
Very good, cos 80. And then again consider this Laplace inverse of f2s. But it is exactly similar. So write it s upon s square plus a square. That is also cos 80. Both the functions are same. So one of it is your f1 and other is f2. Function is of t, so f1t and f2. Okay. So by convolution theorem is said. So by convolution theorem we have Laplace inverse of f1s into f2s is integration 0 to t. You should always remember the formula. Formula is important in convolution. They will ask you in the statement itself by convolution. What is the convolution theorem statement? The correct statement you have to identify. So f1u, f2t minus u, d. Okay, put all the values there. So Laplace inverse f1s into f2s. So s upon s square plus a square into s upon s square plus a square is equal to integration 0 to t. What you are doing? What is your f of t? This is your f of t. In that, wherever is t, you are writing u. So it becomes cos a u. Right? And in your f2t, this is your f2t. In that, in place of t, you are writing t minus u. So it becomes cos A into t minus u done into du. Okay, so s into s square, and this term square. So the required thing we get here. So it is Laplace inverse of s square upon s square plus a square bracket square is equal to integration from 0 to t, that itself I'm taking forward, cos au into cos a into t minus u du. Now you have to solve this integration. But in integration, two functions are multiplied and we cannot separate the integration with 2. So how will you solve this?
By using 2 cos A cos B.
2 cos
Correct.
A cos B.
Very good. So for that you will need 2 here. So multiply and divide.
Multiply and
by
divide.
2. Very good. So 2 cos A into cos B. What is that formula? 2cc
Cos A.
Plus B
Cos.
is cos A
cc.
minus.
Right, 2cc cc, that is cos A plus B plus cos A minus B. Use that here in this. So it becomes 1/2 as it is, integration from 0 to t, 2 cos A, this is A and this is B. So it is cos A plus B, cos AU plus AT plus minus minus AU, cos A plus B plus cos A minus B, AU minus AT
Minus A plus AU.
minus minus plus AU, correct, plus AU and DU. So it is 1/2 integration 0 to t AU cancelled. So it is cos AT. Plus here it is AU plus AU, cos 2AU minus AT. And this is with respect to U. Now there is plus in between, so now we can separate the integration. So integration 0 to t cos AT du plus integration 0 to t cos 2AU minus AT du. Okay, what is this integration? Just think integration is with respect to u. So cos AT is the function of t and it becomes variable is u. So you have to integrate with respect to u. So wherever is u function, that will be considered. All other variables are constant then, and cos AT also becomes constant. Right?
Yes.
Right. As integration is with respect to u, function of t becomes constant. So it will come out. So 1/2 there as it is. Integration, what will come out? Cos AT, right? Cos AT into integration 0 to t du. Okay, so first part is done. Plus integration, this is as it is, I'm writing. Plus integration 0 to t cos 2AU minus AT. Correct? Okay, now integrate 1/2 that cos AT as it is. Integration du is
U.
from 0 to t, right? Plus now integration of this cos, is this term correct? Let me just check. 2AU minus AT, yes. Okay, what is integration of cos? Here is the function of u. This is the term which is having u. So you have to integrate this cos. What is that integration of cos?
Sine.
Sine, very good. Integration of cos is sine, the angle as it is, upon derivative of this term with respect to u. What is the derivative?
2A.
2a. And t's term is constant if you are integrating, so derivative of this constant is 0 and this is 2a. From 0 to t. It is like cos AT, upper limit t minus lower limit 0, plus here upper limit is t, so it is sine 2AT minus AT. Let me write 2AT minus AT upon 2a minus lower limit u, you are writing 0. So this is 0 sine minus AT upon 2a. Okay, that is 1/2 t cos 80 plus this is sine 280 minus 80 sine 80 by 2a, and sine of minus theta. What is sine of minus theta?
minus sine.
Minus sine theta. So outside is minus, minus minus becomes plus sine 80 upon 2a. So they should get added together. 2 by 2 sine. So 2 to get cancelled. Sine 80 by a, that is 1/2 into t cos 80 plus it is 2a sine 80 upon, I don't know, just let me check. 2 sine 80 upon 2a. Sorry. It is 2 sine 80 upon 2a. Add 2 to cancel. So 1/2 will go in now. T cos 80 by 2 plus sine 80 by 2a is the answer. So now the part here you have to do is integration, and you should know the integration formula. But once again you are lucky, as we have online exam, right? So there can be only statements. They will never ask you to solve whole question like solve this by convolution theorem. Okay, so statement is important, and the questions which are like 2-3 liners, or they can be asked. You must remember this theorem, it is important. You can write down statement is important. Is there any doubt?
No.
Sure. So we'll go to the next question. Find Laplace inverse of 1 upon s square into s plus 1 square by convolution theorem. If you will not use convolution theorem, how else you can solve this?
Partial fraction.
Partial fraction. Very good. So you can always separate these terms and solve by partial fractions. Or you can try with first shift also. Wherever is s, is it possible for you to write s plus 1? You can check. If possible, you can use that also. But if they have specified like use convolution theorem, then use convolution only. Okay, so by convolution theorem means you should first identify the two functions which are multiplied together. So can you just tell me the two such functions which are multiplied? In this case,
1 upon s square.
right? 1 upon s square, and second is 1 upon
1 up.
s plus 1 square. Very good. So you have to now take Laplace inverse of both of them. The Laplace inverse 1 upon s square. What is that?
T.
T, right? Or you can say t raised to 2 minus 1 upon 2 minus 1 factorial if you don't remember. So it is t raised to 1 upon 1 factorial. That is t. And Laplace inverse f2s also will need. So Laplace inverse of 1 upon s plus 1 square. Okay, first of all, is it standard form?
No.
No, right? So how will you solve this?
E raised to minus 1t.
Correct. First shift. Very good. Wherever is s, there is s plus 1. So that 1 will come out as e raised to minus 3. And into Laplace inverse, what will remain?
1 upon
s square.
Right. So 1 upon s square means
t.
t. Okay. So you will call one as f1 and other as f2. It is up to you to whom you call f1 and whom you call f2. तर इथे तुम्ही याला f1 म्हटला तरीही चालेल, याला f2 म्हटला तरीही चालेल, किंवा याला f1 याला f2 म्हटला तरीही चालेल. ठीक आहे, चॉईस इज अप टू यू. आता मी सांगते का म्हणायचंय. सो बाय कॉन्व्होल्यूशन थिअरम, Laplace inverse f1s into f2s is integration 0 to t what f1, what is that? F1
U
u into f2
F minus
t minus u d. This is the formula, remember that. Okay, so f1 एक फंक्शन आहे की जिथं फक्त तुम्हाला u करायचंय t चं, ठीक आहे, आणि दुसरं असं आहे की t मायनस u करायचंय. पण याला जर t मायनस u करायचं तर इथेही करावं लागेल, इथेही करावं लागेल, जास्त काम झाल्यासारखं वाटेल जर याला f2 म्हटलं आणि याला f1 म्हटला तर. ठीक आहे, मग याला जर तुम्ही f1 म्हटला तर याला फक्त u करायचा आणि इथे t चा t मायनस u करायचा, म्हणजे एकच चेंज होईल. समजते तुम्हाला? इट
Yes,
इज
ma'am.
इमटेरियल की तुम्ही कुणाला f1 म्हणताय आणि इकडे कुणाला f2 म्हणताय. इट इज युअर चॉईस. आणि जर याला f1 म्हटलं असेल तर इकडे तुम्ही f2 म्हणू शकता, नो डाऊट. ठीक आहे, एकाला f1 एकाला f2, पण जिथे आपण t चा t मायनस u केल्यानंतर कमी काम दिसते तिकडे जाऊया. काम इथे कमी दिसते, इकडे दोन ठिकाणी होईल. ऑल राईट, सो आता ह्या
Yes,
व्हॅल्यूज
ma'am.
ठेवा. राईट, हा, इट इज लॅपलेस इन्व्हर्स ऑफ f1s 1 upon
S
s square into 1 upon s plus 1
plus bracket square.
square is equal to integration 0 to t f1u. What is f1u? त्यामध्ये u ठेवा, e raised to minus u into u, right. इथे पूर्ण याला u म्हणा आणि इथे काय म्हणा, f2t मध्ये t ला t minus u म्हणा. काय घ्याल? t minus u. f2 मध्ये t ला t minus u करा. एकच ठिकाणी t होता, t minus u झाला. And with respect to u. Is there any doubt in this step? You can ask now. Do you have
No.
any doubt? Good. So it is
No.
Laplace inverse of 1 upon, like they asked you, 1 upon this is equal to integration 0 to t e raised to minus u. I'll multiply it inside. Can I do that?
Yes.
ut
Minus u square.
किंवा मग मी हे पूर्ण याला मल्टिप्लाय करून ओपन करू का? दोन सेपरेट टर्म्स होतील. e
Yes,
raised
ma'am.
to minus u t done minus e raised to minus u into u square. Is this correct?
Yes.
Now
ma'am.
yes, you can separate this. Integration 0 to t e raised to minus u t du minus integration 0 to t u square e raised to minus u du. As integration with respect to u, in this case what will come out? u सोबत इंटिग्रेशन आहे म्हणजे t कॉन्स्टंट झाला, so t
Yes.
will come out. Integration from 0 to t u e raised to minus u du minus integration 0 to t u square e raised to minus u du. Yes, now we have to solve this integration. How will you solve?
Leibniz rule.
Very good. So this is your u and this is your v. With respect to u आहे, याचं पुढचं डेरिव्हेटिव्ह 1 होईल आणि त्याच्या पुढचं 0 होईल. And in this case, what is u and what is v? This is
Where is u?
right, and this is v. Correct.
V.
So I'll apply it here. T into u v1 integration of this
E raised to minus u
upon
minus 1.
minus 1. Right? Integration of e is e and derivative of this minus u is minus 1 should get divided. Minus मध्ये sign. u v1 minus u dash 1 v2. Next integration
E raised to minus u
upon minus 1 into minus 1 square plus 1 लिहिला तरी चालेल. याचं पुढचं डेरिव्हेटिव्ह
0.
0. So it is over 0 to t. Right. Minus. This is u. So u into v1 e raised to minus u upon minus 1. Minus derivative of this
2u.
2u into integration of this e raised to minus u upon minus 1 square plus minus plus. Derivative of 2u. 2 integration e raised to minus u upon minus 1 cube. And next derivative of this will be 0. So this is over, and from 0 to t. Right, this is from 0 to t. Okay, now put upper lower limits. If upper limit is t, कुणाच्या जागेवर ठेवताय upper limits?
U.
u integration हे आहे u सोबत, so you are placing it on u. So u ला आधी t ठेवा, t e raised to minus t upon minus 1, t is outside, upon minus 1, so minus can go there, minus e raised to minus t upon हे काय plus है ना, minus 1
Yes.
square is plus 1, so this minus as it is, minus e raised to minus t. upper limit minus lower limit. आता u ला ठेवताय तुम्ही 0, u ला 0 ठेवला तर हे काय होईल, 0 into anything 0, so 0. Next is minus e raised to 0 minus 1. Here it completes the first, plus second, sorry, minus is there, so minus upper limit u ला t ठेवा, t square e raised to minus t minus minus t square e raised to minus. Next, this is plus 1, so minus is there, 2t e raised to minus t minus. Next, this is minus, so this becomes minus 2 e raised to minus 1 cube is minus 1, right? So it becomes minus 2 e raised to minus t. Minus 2 e raised to minus t. This is the upper limit minus lower limit. Lower limit you are writing 0 for u. So 0 into anything, this is 0. 0 into anything, this is also 0. So two terms are 0 there. 0, 0. Next term is minus, this is minus 2 e raised to 0, that is 1. So minus 2. Is everything correct? Can you just check and tell me?
हॅलो मॅम,
Yes, beta.
मायनस टी स्क्वेअर पाहिजे ना.
पहिला
Second.
term, okay, let me check. E raised to very good, beta. Minus, I take minus sign, very good. Minus t square. Thank you. आणखी काही check करा आणि सांग. बाकी minus minus all three are minus, correct. Very good, beta. Chal, so this t will multiply inside, so it is minus of t square e raised to minus t, then minus t e raised to minus t, then this is plus 1 into t, that is t, this is minus minus plus t square e raised to minus t, again plus 2t e raised to minus t, plus 2 e raised to minus t, and this is minus minus plus, but outside is minus, minus 2. Check. So these two terms get cancelled. 2t e raised to minus t, t e raised to minus t. 2t minus t, it is t e raised to minus t. This is done. Then plus t and minus 2. So this is your answer. Just check. Is this correct? Any problem, anything, anywhere? Everything is good? Correct? Are you getting the similar?
Ma'am, plus 2.
Sorry, beta?
Plus 2 should be there, no?
Plus 2. Minus minus is plus, पण बाहेर एक minus आहे ना? Original minus आहे बाहेर. So हा minus आणि तो plus. It will be minus. Correct?
Yes, ma'am.
Good. So yes, that is the answer. Any doubt you can ask now? Okay, next question. Find Laplace inverse of 1 upon s plus 3 into s plus 1 by convolution theorem. So F1s is here?
1 upon s plus 3.
Correct. Two functions. So it is 1 upon s plus 3. And F2s is?
1 upon
Correct. So Laplace inverse of F1s is 1 upon s plus 3. What is that?
E raised to minus
Very good. E raised to minus 3t, call it as F1t. Second, Laplace inverse of F2s is Laplace inverse of 1 upon s plus 1. What is that?
e raised to minus t.
Correct. Call it as, very good. Call it as F2t. So now by convolution theorem, Laplace inverse F1s into F2s is equal to, tell me the statement, integration,
from 0 to t.
right? F1,
U
correct,
U
into
f to t
F2
minus
t
u.
minus u with respect to u, correct. So that is Laplace inverse F1s into F2s, do that multiplication, 1 upon s plus 3 into 1 upon s plus 1 is integration 0 to t F1u. What do you write here? What do you
E
write? Yes, e raised to
Minus 3t.
minus 3
U.
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 F1 u you are going to write. So t you are writing u into F2 t minus u. So what you will write? E raised to F2 मध्ये t च्या जागी minus sign तिथेच आणि t च्या जागी लिहा t minus u. So t minus u du. Got it? So yes, this is equal to E is the base. So addition of indices will happen. So it is equal to Laplace inverse 1 upon s plus 3 into s plus 1 is equal to integration 0 to t e raised to minus 3u. काय तिकडे बघा बरं? E raised to minus t
Minus t plus
plus
u.
u.
minus t plus u.
Correct. So minus t plus u du. It is integration 0 to t e raised to how much? Minus 3u plus u. Minus 2.
Minus 2u minus.
Right. So now you can integrate this. Or simply t's term you can take out. So it is e raised to minus 2u into e raised to minus t. No need to take that in t's term. Right? So here it is constant. Whole term is constant. Will come out t's term. And it is only the integration of e raised to minus 2u. Right?
Yes.
So what is integration of that? E raised to minus 2u, only one term
E raised to minus 2.
upon minus 2. Correct. From 0 to t. That is e raised to minus t. Upper limit u च्या जागी ठेवताय t upon that minus 2 as it is. आणि minus sign देऊन u च्या जागी 0 ठेवताय. So e raised to 0 upon minus 2. It is e raised to minus t. My e raised to minus 2t upon minus 2 minus minus plus e raised to 0 is 1 upon 2. So here 1 upon 2 is common, you'll take it out. So e raised to minus t by 2 into, here it is 1 and here it is minus e raised to minus 2. That can be the answer. So are you getting now what is convolution theorem?
Yes.
Good.
Yes, ma'am.
Very good. We'll take the next question. Find Laplace inverse of s upon s raised to 4 plus 13 s square plus 36 by convolution theorem. By convolution theorem. Okay. So yes, they have said convolution theorem means there should be multiplication of two terms. But if you see here, there is no such multiplication we can easily see. So what next then? Can anyone tell me here?
Substitute
Yes, you have to factorize this. How will you factorize? 36 into 13. Such two numbers whose multiplication is 36 and addition is 13.
9 and 4.
Compose.
9 and 4
Yes.
into 4 is 36 and plus 4 is 13. So yes, 9 and 4 are the two such numbers. So what are its factors? S raised to 4 plus 13 s square plus 36. It can be written as
S plus 9 S plus
very good. S square यामध्ये फॅक्टर असतो LD मध्ये बघितले आपण. So s square plus 9 into s square plus 4. So this can also be written like this. You must try the factorization if it is convolution, because we need two terms there, and there are such two terms which we can get by factorizing. Everyone is getting?
Yes.
Right. So that your given thing becomes Laplace inverse of s upon is equal to Laplace inverse of s upon s square plus 9 into s square plus 4. To solve this is nothing but to solve this. Now by convolution theorem, there should be two functions f1s and f2s. So can you just tell me f1?
S upon S.
Okay. So s upon s square plus 9 you said. So what will be the second?
1 upon S square plus
1 upon. Very good. So this yes you can either give to this or this. No problem, you can give to anyone. कारण आपल्याकडे एकच याचा आहे तो कुणाला तरी एकालाच जाईल. ठीक आहे. So एक 1 upon होईल आणि एक s upon होईल. So it's your choice. If you say give to this, I'll give to this, or you can write here also if you want. Is there any doubt? S स्क्वेअर जर असताना इकडे तर दोघांनाही एस गेला असता, दोन एस होते, पण आता एकच. एक मिनिट हा. Okay, so it is s upon, I have given to 1 and second is 1 upon. So Laplace inverse of, we have to consider okay, so we are taking Laplace inverse of f1s. So Laplace inverse of s upon s square plus 9. What is that?
3t.
First rate. Correct. And Laplace inverse of f2s is Laplace inverse of 1 upon s square plus 4. What is that?
1 upon
2. It is 4 means 2 square, right? You should first write it as 2 square. So 1 by 2 sine 2t. Right? So one you will call f1 and other you will call f2. Now we have this. So by convolution theorem, is equal to integration 0 to t f1 u into f2t minus u du. Okay, put all the values there. So Laplace inverse s upon s square plus 9 into 1 upon s square plus 4 r2 values. Integration 0 to t f1u. What is f1u? Cos 3u.
3u.
Right. Cos 3u into f2. F2 is what? 1 upon 2, no? So 1 upon 2 sine 2 t. T is t minus u. T. Okay, so 1/2 will come out here. And it is integration from 0 to t. Sine. I'll write sine first. Sine 2t minus 2u into cos 3u. 3u. How will you solve this integration?
2 sin is cos b.
Right, you will need 2 there. मी फक्त हा बाहेर काढलाय, हे 2 ने मल्टिप्लाय केले आतमध्ये, साइन आणि cos as it is दिलाय. पण yes, we cannot separate the integration in multiplication, so we need the formula of 2 sin a. So multiply and divide that. Okay, what is that? 2 sin a cos b.
Sin A plus
Sin a plus b
Plus sin a.
plus
plus sin a minus b. Correct. So apply it there. It is 1/4 integration 0 to t 2 sin a cos b sin a plus b 2t minus 2u plus 3u plus sin a minus b 2t minus 2u minus 3u d. So it is 3u minus 2u u. Integration 0 to t sin 2t plus u, right? Sin 2t plus u. Put it. Sin 3u minus 3u minus 2u minus 5u. So sin 2t minus 5u plus sin 2t minus 5u du. Correct? We have used a formula, so we'll take the integration. Now, what is integration of sine?
minus
Very good. Minus cos, and derivative is plus cos. Please remember. So minus cos 2t plus u upon what?
2
Now we are with respect to u. Right, 1. Now here integration of sine, again minus cos 2t minus 5u upon derivative of this with respect to u
minus 5
minus 5. T constant 0, derivative of this is minus 5. And this is from 0 to t. It is 1/4. First, for that you will write t. So it is minus cos 2t plus t, 3t. Minus minus becomes plus cos. You let it here 2t minus 5t minus 3t. Okay, that is upper limit. Minus lower limit now you let 0 theva. That is minus of cos 2t. इथे पण u ला 0 ठेवा, हा प्लस आहे, मायनस मायनस प्लस cos 2t by 5 u 0, so it is cos 2t by 5. Right, connect it. 1/4 minus cos 3t. Cos of minus theta is what?
Cos theta.
Cos theta, so it is cos 3t minus minus plus cos 2t minus plus minus cos 2t by 5. The plus and minus get cancelled, I guess. Is this correct?
Yes.
Right. Okay, so it is 1/4 into 1 minus 1/5 cos 2t. 1 minus 1/5 together. 1 minus 1/5, 5 minus 1, 4/5.
4/5.
4/5 cos 2t. 4 get cancelled here. And the answer is cos 2t by 5. 1 by 5 cos 2t. Correct? Eh?
Yes.
So such questions are there in convolution. So you can try more. Chal, write some homeworks. Find inverse Laplace transforms by convolution theorem. So the first question you will write here. Laplace inverse s square upon s raised to 4 plus 13 s square plus 36. This is the same, but here it is s square. म्हणजे दोघांनाही s जाईल आणि दोन्ही टर्म्स काय असतील? Cos.
Cos.
Right. Correct. Next, right now. Laplace inverse of, there are so many questions, so you can just try them. 1 upon s minus 2 into s plus 2 square. Third, Laplace inverse of s plus 3. Take this s square upon s square plus 2 square bracket square. And the last one. Laplace inverse of 1 upon s into s plus 3 square. All of them by convolution. And all of them you can also try by partial fractions. So if you are done with convolution, try with partial fraction. How many methods we have completed in inverse Laplace? But Laplace is very important. Inverse Laplace, the basic formulae, first shift theorem, the starting part, convolution मोठे आहेत examples, convolutionचं statement, partial fraction जे मोठे आहेत, so partial fraction not possible. तिथे तुम्हाला MCQ ला विचारलं जाईल. Convolutionचं statement विचारलं जाईल. ठीक आहे, बाकी questions तर मोठे आहेत. चलो. Number of method. Method number next is
Fifth.
method. I guess we have seen linearity, then first shift, then partial fraction, and then convolution. 5.
Yes.
Right. So next method give the heading inverse Laplace transform of logarithmic and inverse trigonometric. Inverse trigonometric functions. Inverse Laplace transform of your functions will be particularly log or inverse trigonometric. What is inverse trigonometric? Trigonometric, you know, sine, cos, tan, and inverse of that means function should be like tan inverse, cot inverse, and logarithmic functions, so log s square, like that. Tan inverse, as it is what? Inverse. So all the functions are in S. So such functions where log and inverse trigonometric are there, there is the special case to find inverse Laplace transform. So we'll write the statement of that. For that, you can just tell me in Laplace, okay? Before we go to inverse Laplace, you just tell me the statement of derivative of Laplace transform. I'll write it here. If Laplace of f of t is f of s, then Laplace of f dash of t, derivative of the function. What is that?
-1 divided.
No, that that is multiplication by t. On other hand side, you are taking derivative. But if you are taking derivative on left hand side, what do you do on other side?
D by D.
Yes. You don't remember.
I take f of s by
No, that is oh boy, you have forget already.
plus f of 0.
No, that is correct. What is that? Do you remember?
S into f of s.
S into f of s minus f of 0. आपण एक मल्टिप्लिकेशन बाय टी बघितला, एक डिव्हिजन बाय टी बघितला, एक डेरिव्हेटिव्ह बघितलं, एक इंटिग्रेशन बघितला प्रॉपर्टी. मल्टिप्लिकेशन बाय टी जेव्हा आहे तेव्हा काय केलं आपण इकडे पलीकडे मायनस टी रेस टू एन सपोज असेल तर मायनस 1 रेस टू एन डेरिव्हेटिव्ह घेतला पलीकडचा. डिव्हिजन केल्यावर इकडे काय केलं इंटिग्रेशन घेतलं एस टू इन्फिनिटी. आणि इकडे जर फंक्शनचे डेरिव्हेटिव्ह घेत असाल तर इकडे केला तुम्ही एस इंटू एफ ऑफ एस मायनस एफ ऑफ 0. आणि जर इथे डबल डेरिव्हेटिव्ह असेल तर एस स्क्वेअर एफ ऑफ एस मायनस एस एफ ऑफ 0 मायनस एफ डॅश ऑफ 0. हे असे फॉर्म्युले आठवले का?
Yes, ma'am.
Right, that is the derivative. I was asking about derivatives. So you should please remember this. These are important. And last was integration. जेव्हा तुम्ही इंटिग्रेशन घेताय तिथे particularly 0 to t लिमिट्स पाहिजे आणि पलीकडे काय करता मग
f of s upon s.
One upon
f of s upon s. Correct. We write upon s. So here f of s is. Please remember e raised to n f of t upon t f of t derivative of f of t integration of. So here you should get confused in these 4 properties. इकडे t, इकडे derivative, इकडे derivative, इकडे yes. t, इकडे derivative. ठीक आहे आणि इकडे derivative, इकडे yes. You have to remember. ठीक आहे. So I was asking that Laplace of f dash of t is s f of s minus f of 0. ठीक है. So, and can you just tell me also Laplace of t f of t? We'll need that also. What is Laplace of t f of t? Here, multiplication by t minus of t by ds of f of s. आता हे सगळं आपण इनव्हर्स मध्ये घेऊयात. ह्या डेफिनेशन सगळ्या तुम्हाला प्रॉपर्टीज जर आठवल्या असतील तर आपण जाऊयात आता त्याच्या इनव्हर्स लिहायला. Remember this, if Laplace of f of t is f of s, then Laplace of t f of t is minus of t by ds of f of s. Let me take it forward. So if Laplace of f of t is say f of s, then Laplace of f, sorry, not dash t, we need t now. So Laplace of t f of t is minus of derivative of f of s, I'll call f dash of s. So we'll now convert it into inverse Laplace. So if Laplace inverse of f of s is f of t, then Laplace inverse of f dash of s, इथे निगेटिव्ह साइन आहे, इकडे नाही दिलं तर ते इकडे जाईल. So it is what? Laplace inverse of f dash s will be what? Minus t into f of t. पण f of t म्हणजेच काय? Laplace inverse of f of s आहे. F of t is Laplace inverse f of s. So Laplace inverse of f dash of s is nothing but minus t into Laplace inverse of f of s. So if you want now Laplace inverse of f of s, this minus t should get divided on other hand side. So 1 upon minus t into Laplace inverse of f dash of s. So forget everything, remember this. जेव्हा तुम्हाला फंक्शनचे लॅप्लास इन्व्हर्स काढायचं असेल आणि ते फंक्शन लॉग किंवा इन्व्हर्स ट्रिग्नॉमेट्रिक असेल, तेव्हा तुम्हाला त्याचं आधी डेरिव्हेटिव्ह काढायचंय फंक्शनचं एफ डॅश एस, त्याचं लॅप्लास इन्व्हर्स घ्यायचंय आणि त्याला -1/t ने मल्टिप्लाय करायचं. Write this properly. Please remember the steps. Whenever there is log or inverse trigonometric functions, if you want to take its inverse Laplace transform, so you will first find its derivative. In case of these two functions, you'll find its Laplace inverse, and whatever the answer comes, you will just multiply by -1/t. We'll take one question and then we'll stop. Next lecture we can see then. Just one question. Find Laplace inverse of log s plus a upon s plus b. How is the function? Laplace inverse of f of s, पण ते f of s कसा आहे? log. Right? एक तर तो log आहे का बघा, किंवा मग इन्व्हर्स ट्रिग्नॉमेट्रिक आहे का बघा, त्याच्यासाठी एक आपली स्पेशल मेथड आहे. So yes, it is log function. So log function आहे, तर let it first call f of s. Let f of s is log of s plus a upon s plus b. Okay, to solve this, the method is you first have to solve what?
Derivative of the function.
Derivative, very good. So f dash of s. Log a upon b, we don't know the derivative right now. So first thing is, what do we know is log a upon b is?
Log a minus log b.
Correct. So we'll do that. So it is log s plus a minus log s plus b. Log a upon b is log a minus log. Now we can take the derivatives. What is derivative of log?
1 upon s plus.
Correct. One up derivative of log something is 1 upon something into derivative of that something. Please remember. So derivative, you are taking derivative. So derivative on both sides with respect to s. So derivative of log is 1 upon something into derivative of that something. What is it?
1.
With respect to, yes, it is 1. Minus, what is derivative of this?
1 upon s.
S plus
Correct.
b.
1 upon s plus b. Very good. And now you have to find its Laplace inverse. So take Laplace inverse on both sides. It is Laplace inverse of 1 upon s plus a. Can we separate Laplace inverse? Yes, by linearity. Right. So we get Laplace inverse f dash s as, what is that?
E raised to minus a.
Minus a t. Don't forget t. E raised to minus a t minus, what is next?
E raised to minus
E raised to minus bt. Correct. So we have Laplace inverse of f dash s, and we know, now we'll write that. What do we know? We know that. What do we know? Laplace inverse of f of s is minus 1/t into Laplace inverse f dash of s. So put all the values there. So Laplace inverse of log s plus a upon s plus b, that was our f of s, is minus 1/t into Laplace inverse f dash s. We have the answer for that. E raised to minus at minus e raised to minus bt. Done. Finished. If you want to multiply inside by that minus, so it becomes e raised to minus bt minus e raised to minus at upon t. Easy. Just remember, whenever log or inverse trigonometric, you have to take derivative and Laplace inverse of that derivative, and whatever the answer comes, you will just multiply it by minus 1/t. That will be the required answer for log or inverse trigonometry. Is there any doubt? So write one homework so that you can do this. Find Laplace inverse of log s square plus a square upon s square plus b square. Just try. If you can't, we'll solve it in next lecture. And also find Laplace inverse of log 1 plus a by s. Just try. If not possible, we'll do this. Don't leave, please wait. Let me take attendance. Okay, all of you will do the homework, and once done, you will send it to me on WhatsApp. I'll check. Let me see how many of you will do it. Few people does it regularly, but let me check all of you. I'll expect that all of you will send it to me today. There will be 122 messages to me. Chalo, then we'll stop. Is there anything else you want to ask? Just a minute.